Don't get confused. You're fine. I promise. All right, so moving on to active transport. So remember, not all substances can move freely into a cell. So those guys that are wearing the flip-flops and basketball shorts and like a t-shirt with like a barbecue stain on the side, they're not going to be easily let into that club. That bouncer is probably going to say, no, sorry bud, try somewhere else. Okay, so but in that case, some molecules have to be pushed uphill against a concentration gradient. So maybe that guy's going to have to pay off the bouncer. He's going to have to give up some money, or he's going to have to wait in a long line, and the bouncer is going to see if it's busy or not. And if the club is not busy that night, then he might just be like, okay, dude, like come on in. But if not, if it is super busy, yeah, no, he's probably not going to get into the club. But he's going to have to try something really extra in order to make it inside. Okay, but so in terms of concentration gradients, this means that substances are moving from an area of low concentration to an area of high concentration. So in this example, this guy is he has to get on the subway to get where he needs to go, despite the amount of people, despite that there's no more room, despite that it's probably not going to be too pleasant squishing inside that subway, but he's got to get there. He has to get to work, so he is going to enter that crowded subway. He's going to leave the nice vacant subway area, and he's going to enter that subway train, that subway car, and he's going to be very squished. Okay, and so there are some substances that are too big to move through a protein channel, and so they have to be enveloped by the cell or excreted by the cell. So these ones are even bigger than like glucose or sodium that we were talking about earlier, and so they must be enveloped by the cell or excreted by the cell, and this is called endocytosis and exocytosis. Endocytosis or exocytosis. Okay. All right, so the first type of active transport that we're going to talk about right now are molecular pumps. And so when a cell uses energy to pump molecules across the membrane through a protein channel, this is called active transport by molecular pump. And so this allows a cell to concentrate key molecules within the cell or to remove waste quickly from the cell. So in this example, we're talking about calcium, potassium, chlorine, and sodium. These are all ions. If you recall from Unit 1, this means that they are charged particles. And so we're talking about this. So this allows the cell to concentrate key molecules within the cell. So think about it, if you've ever thought about how a battery operates, we're going to talk about this when we talk about neurons, we talk about our nerve cells, but batteries operate by creating a separation of charge, and so they want to build up a charge on one end of the battery, and when it comes time to needing to use that energy, they allow that buildup of charge to kind of move down its concentration gradient. And so when you can make a buildup of positive or negative charges, you are kind of charging that cell like a battery. You're setting up a gradient, you're setting up a super high gradient on one area of the cell and a super low gradient in the other area of the cell. And you're doing this using ATP and using a molecular pump to exchange those molecules. So down here in the example, we're looking over here, there are areas of concentration, and when you input energy here over time, we're going to end up with an area of high concentration and an area of low concentration. And so again, this is what we call setting up a concentration gradient. You're setting one up. You are forcing it to do what you want it to do. And again, this is like a battery. This is basically like a charged battery, so that when we stop this pump, all that stuff can move back in and we can use that to perform cellular work. Okay, and then this is just a little GIF showing this specific pump is called the sodium-potassium pump, and you will hear that term many times over the course of your scientific life. So this is just showing how, like, this is sodium and potassium. So potassium, Drake is pushing 2 potassiums inside the cell, and then he is hitting out 3 sodium molecules. So you are setting up a gradient. So if you're moving out 3 pluses and you're moving in 2, by definition, you're setting up more pluses, more of a positive charge on the outside. And so again, you're charging that battery. So thank you, Drake, for that lovely demonstration. Okay, so those two words that I said earlier, endocytosis, exocytosis, yeah, let's talk about what that means. So endocytosis, a form of active transport, so right off the bat, you know that it takes energy to do it and it has to move from high to low, or sorry, from low to high. So endocytosis is when a cell uses energy to import large amounts of materials into the cell using a vesicle. So either we're importing huge molecules or we're importing a lot of them and we need to do it quickly. Okay, and we use this using a vesicle. And so we use vesicles for a variety of different things, a variety of things. If you recall this word from the first concept one, about how we use vesicles to transport proteins, when we also use vesicles to transport just other large amounts of materials. And so this is an example of endocytosis, and I'll show you a little GIF in just a second. And so an example of endocytosis would be a white blood cell when it engulfs bacteria to fight infection. So remember I told you about, I think I was thinking about lysosomes as Pac-Man, how they eat stuff, engulf stuff. So I want you to think about Pac-Man when you're thinking about endocytosis. So they engulf stuff, they engulf things. Okay, then the second form of active transport is called exocytosis. And so exocytosis is when a cell uses energy to export large amounts of materials out of the cell, again, using a vesicle. And so an example of exocytosis is when a nerve cell releases neurotransmitters to pass signals to the brain. Let's say we have a nerve here and we have your muscle right here. Okay, so this is called a neuromuscular junction. Okay, so let's say this is the nerve that's controlling your leg that can like move up or down. Okay, so right here, so again, this is the neuron, this is the muscle, so this is called the neuromuscular junction. So your nerve cell is going to release neurotransmitters, and those are going to be little tiny molecules like acetylcholine. I don't know if you've ever heard that word. Stuff like dopamine, serotonin. Yeah, sound a little bit familiar? Okay. So those are called neurotransmitters. And so your nerve cell is going to release those neurotransmitters, and those neurotransmitters are going to dock themselves on your muscle, and that is going to send a signal. That docking sends a signal, and it starts a whole cascade of signals that eventually cause your leg to rise. Okay, but so that process of the release of those neurotransmitters at that junction is called exocytosis, or it is done through the process of exocytosis. Okay, so then here's just a little GIF showing that. So endocytosis, this is when the plasma membrane kind of closes in on itself and it creates that vesicle. Okay, so they're taking in about like maybe 4 of those molecules. Yeah. And then over here we have exocytosis, so it was using a vesicle, and then eventually that vesicle collided with this membrane, and it joined that membrane, and then it released all of those different molecules. All right, practice time. So see if you can complete this chart, and we will go over it as a class when we are done. All right, well, this has been Unit 2, Concept 2, and I'll see you guys next time.